Welcome one and all. Today's this meetup is for the presentation of the bank marketing effectiveness prediction. This is a project of classification, and this project is undertaken to decide or to get know that either the customer gets convinced to take term from the bank, and for that purpose, the campaign by the bank is the campaigning by the bank is undertaken, and we have to uh, develop a a model to check either the customer gets convinced for the bank or not. And for that, we have prepared this Colab notebook in which we have implemented different different machine learning algorithms for the classification purpose. And classification is for to see either the customer is convinced or not. And that is why this project is uh, distributed under classification type. Now let's look at the project. Now some information regarding the project. This is a bank marketing company project. Nothing but the work is marketing campaign by the bank is done, and the data set that we are provided with consists of 45,211 rows are there in the data set, and there are 17 columns, right? And including that 17 columns, there are 10 categorical columns. For this, we have implemented four different machine learning algorithms. Namely, first one is the logistic regression, then second one is a random forest, then XGBoost, and then KNN. These four machine learning algorithms we have implemented, and among these four algorithms, the XGBoost algorithm has been found the best model for this classification type of project. And such a conclusion is given in the summary part of the project. Now, one by one, all things we will see. Um, Now, this is the GitHub link of my project. Now, here the problem statement regarding this banking institution, or the which type of campaign they have uh, deployed, and then we have to make the we have to find its effectiveness. Some general guidelines are given here to implement or to make the project successful. Let's begin with our data loading to the Colab environment. For this, we have to first of all some libraries we have imported here for the various purposes, as you can see here. After that, we have loaded dataset, that is the dataset file I have uploaded in my Google Drive, and then the access of Google Drive is given to the Colab notebook by applying this code. That is, the Google Drive is mounted with Colab notebook, and for that this code is given here. As you can see here, these are the columns, or we can say these are the variables which have we in our data set, and this information is occupied in the our columns. Our dataset has 45,211 rows and 17 columns. Now, this is the first view of the dataset by applying dot-head function. Now, let's see the bottom 5 rows of the dataset by applying dot-tail function. Now, see some sample rows from the dataset. We have seen here 5 sample rows by applying dot sample function. Now we know that is the dataset has 45,211 rows and 17 columns, and we can check the number of rows and number of columns by using dot shape function over the dataset name. Now, to check the information of the dataset, we have a function that is dot info. By applying or by running this code, we will get know how many columns are there. As we can see, this number 16 is the index number. That means and indexing is started from 0, means we have total number of columns are 17, and each column has this much of non-null values, means the column, or we can say the variable education has 45,211 non-null values, and the data type of that non-null values is object, means this would be the categorical data in the column education or in the variable education. And those columns has the d types, mean data type as integer 64, or at some places it may be float 64. That means that column name or that target or that variable name consists a data type in the numeric form. Now let's check for the duplicate values in the dataset. For this, we have applied a dot duplicated function, and by that by applying that function, we would get know the information in true false format. If there is a false, then there would be no duplicate values, and if there would be true, then it means there would be duplicate values. And in brief, or in a single snap, if we want to look for the duplicated values, then we use duplicated rows dot sum function for the over the duplicate rows, and here you can we can see 0. It means that the sum of duplicate values is 0. Sum of duplicate values is 0 means there are no any duplicate values. Now let's check for the missing values. For that, we have applied a function is null dot sum. That means this function will gives us the sum of null values, right? And here we got the sum of all null values for the respective column. For age it is 0, then likewise for marital it is 0, likewise for balance column it is 0. For all columns the values are 0. It means there are no null values in the dataset. As we have to finish this presentation within 25 minutes, therefore it may be a case that some part of the presentation I may skip, but you will be provided with this collab notebook to get all the records and data and to check and to view all the scrupulous data and information and findings with code. Now let's get understand about the variables. That is the which different variables or columns we have in our data set. By to see the columns, we have a function dot column. By running that code, here we got the total 17 columns, and as we know, there are total 17 columns, namely, and the names of that 17 columns are age, job, marital status, then education, then default balance, then housing, then loan, then contact, then date, then month, then duration, then campaign, then P days, then previous, then P outcome, then Y. Y is nothing but the here we have a categorical information in the column Y. That is S no type values are there. That is the two categories in column Y. One category is one S and second category is no. That means either the customer is convinced or not. Let's look the description of the dataset. For that, we have the dot describe function, and this include is equal to all is for to get all the rows. If we does not enable this include is equal to all function, then it will this describe function gives us only the value, only the description of the columns which are numeric in form, and this dot t is to make the rows transformation. Now let's jump to the ML algorithm part. These are the this is the description part of the variables. That is the what each column means. That is the it is the nothing but the age of that client or that customer in numeric form. Means that is the means this data is stored in numeric form. Then job column is nothing but the this column consists of the which type of job that client or customer is doing, and it is a categorical. Then the categories for the job are maybe admin, then blue collar job, then entrepreneur, then housemaid, then maybe manager, maybe retired person, or maybe some self-employed. Right? These are the categories in the job mm, column or job variable. And likewise, all variables are mentioned here. Now we are jumping towards the implementation of the ML algorithm part. As previously, I have told you that we have implemented total 4 ML algorithms, and for that, before implementing ML algorithm, some necessary or some pre-processing work is done here. That is the we have handled outliers. That is removed some outliers and the columns where we have some values more than or some null values are there or some non-essential values were there. Such a column, one column was there which have more than 50% data was null. That column has been removed. Such a pre-processing or prerequisite processing work is done here, as you can see here. And after that, I have implemented the ML algorithms. Then here it is the correlation heat map among the different variables. And from this correlation heat map, you can see it is very difficult to say have any strong correlation between any two variables, right? only the highest correlation value we can see here is the only 0.45 between the p days and the previous, right? This is the only highest value. That is, it means that there is no any strong correlation between any variables. Now this is the pair plot. Now after doing all pre-processing work, let's again take a look at the data set. For that we have again to see that we have again uh, used dot head function. This is the class imbalancement. That is the we have done work for the imbalancing or class imbalancing. Then we have splitted data into trend data set and test data set, as you can see here. Yes, here we have imported trend test split module from the scikit-learn library. We have also imported grid search cv from the sky scikit-learn library. And then we have then we have splitted data into two data sets, that is the training data set and the testing data set. And for that we have again, after splitting, we have checked for the shape of x train data set and x test data set, and then also we have checked for the shape of y train data set and y test data set, and the respective shape values or the respective shape dimensions are here. These are the functions I have defined functions to classify to for the classification of algorithms, and then to evaluate and visualize the models. Two functions I have defined here to make the or to run the models. Now after being implementing four modules, we have the results of that four modules. As you can see here, four modules we have implemented. First one is the logistic regression. The second one is the random forest. The third one is the XGBoost. The fourth one is the K nearest neighbor. These four modules we have implemented, and after that we have the results of evaluation matrices, right? And from these results you can see the most highest accuracy is given by XGBoost, right? It is 0.93, means about 93% accuracy is given by the XGBoost model. Then in the case of precision, the precision is given highest by the XGBoost, also by the XGBoost, and it is about 94%. And also in the case of recall, the XGBoost is performing best, giving 93% recall value, and F score is also highest of the XGBoost, right? And as the performance evaluation, we can see the XGBoost model is the best among these four models, and that is why we would suggest this XGBoost model as a best performing model among these four models for this classification work for the financial for the purpose of this financial institute to check the effectiveness of their campaign. Okay, thank you. All other necessary things are provided in the same collab notebook, and this collab notebook link will be provided you. And for any other necessary information, the GitHub link is also given here, and you would get any required things from my Git link, and you check the all code and in detailed file with my collab link that I will providing in submission section. Okay, thank you.